All right, today we are cracking open the Builder's Playbook for Amazon Bedrock. We're going to skip the high-level theory and get right into the practical, real-world rules for building production-grade AI applications. Let's dive in.
You know that feeling, right? If you've ever built with generative AI, you've been here. You get that demo working in a notebook, it looks absolutely magical, everyone's blown away, and you think, hey, I'm like 90% of the way there.
And then, reality hits you like a ton of bricks. What happens when traffic goes through the roof? How do you stop it from just making stuff up? And how on earth do you switch out the AI model without having to rewrite your entire app? That last 10%? Well, that's where the real engineering starts, and that is exactly what we're going to break down.
So at the center of this whole playbook is Amazon Bedrock. The simplest way to put it, it's a managed service from AWS that gives you access to a whole bunch of powerful AI models from different companies, all through a simple API call. It takes care of all the heavy lifting and infrastructure so you can just focus on building cool stuff.
You know, the best analogy I've heard for Bedrock is to think of it like a giant food court. You've got all these different restaurants to choose from, right? Some are super fast, some are a little more high-end, some are really budget-friendly. Bedrock is the food court itself. It's the single place you go to order from any of them without having to run all over town. Keep that food court in mind because we're going to come back to it.
So, let's get started. Chapter 1. You're in the AI food court, and the first thing you have to do is decide what you're going to order. This is all about choosing your tool, which in our case is the foundation model.
Now, picking a model isn't just about finding the smartest one. It's really about finding the right one for your specific job. And that means you're doing a balancing act across 6 key things: latency, cost, reasoning, modality, tool use, and context length. Nailing this balance from the get-go is probably the most important first step you can take.
Okay, let's talk about latency, or speed. If you're building a chatbot that people are talking to in real time, every single millisecond counts. You need a fast, snappy model. But if you're just summarizing a long report overnight, well, then you can afford to use a slower, maybe more powerful model to get a really high-quality result. It's all about matching the tool to the urgency of the task.
Next up, let's tackle context. The easy way to do things is to just, cram a massive document into the model's brain and hope for the best. But the pro move is a technique called Retrieval Augmented Generation, or RAG. Think of it this way. Instead of giving the model an entire library, RAG acts like a super smart librarian. It finds the exact paragraphs or data points that are most relevant first, and then it hands just that tiny, focused bit of information to the model. It's way more efficient, it's cheaper, and believe it or not, it's often way more accurate.
And that brings us to this really crucial insight. When your model starts making things up, what we call hallucinating, your first instinct is probably to just swap it out for a bigger, smarter model. But that's not the real fix. The true architectural solution is to ground your model in facts using RAG, and then put safety nets, what we call guardrails, around its output.
Okay, so you've picked your restaurant from the food court. You know what you want. Now, how do you actually place the order? Chapter 2 is all about the actual mechanics of talking to the model you've chosen.
I mean, this is a classic developer nightmare, right? You build your entire application around one specific AI model, and then 6 months later, a brand new one comes out that's faster, cheaper, and better. Do you have to tear everything down and start over? Well, the answer should be a resounding no.
And the solution, in Bedrock, is something called the Converse API. It's like that standard ordering kiosk at the food court. It gives you one consistent, easy-to-use interface no matter which model you're talking to. This means you can swap models just by changing a single line of config. The alternative is Invoke Model, which needs a custom formatted request for every single model. Now, Invoke Model has its place for some really niche features, but for almost any conversational app you're going to build, the flexibility of the Converse API is the obvious winner.
So let's look at a few ways you can talk to these models. The simplest pattern is what we call single shot. It's exactly what it sounds like. You ask one question, you get one answer back. It's a clean, simple transaction, perfect for tasks like summarizing an article or maybe reformatting some text. One and done.
But for a chatbot, you need a conversation, right? And this is where we hit a really critical architectural point. Bedrock itself is stateless. It has no memory. It does not remember your chat history. Your application, the code you write, is responsible for bundling up the entire conversation history and sending it along with every single turn. This is so important. How you manage that history is key to your app's performance and cost.
And finally, we have streaming. This one is a game changer for user experience. Instead of making the user wait for the model to think up its entire long response, streaming sends it back one word or token at a time. For any app where a person is waiting on the other end, this is absolutely non-negotiable. It makes the whole thing feel so much faster.
And to make streaming happen, Bedrock gives you specific APIs for it. So if you're using that flexible Converse API we talked about, you'll use its streaming version, Converse Stream. And if you're using Invoke Model for some reason, yep, there's a streaming version for that too. The rule of thumb is dead simple. If a human is waiting for the answer, you have to be streaming, period.
All right, we've picked our model, we know exactly how to talk to it. Now for the really hard part, making our application robust, scalable, and safe enough to unleash on the real world. Welcome to Chapter 3, Making It Production Ready.
Let's start with scale. When it comes to handling traffic, you've got two main choices. On-demand is basically pay-as-you-go. It's perfect when you're just starting out and your traffic is all over the place. But once you have a steady, predictable workload, you can reserve capacity ahead of time with something called provisioned throughput. This guarantees your performance and usually ends up being cheaper at scale. It's like having a reserved table at the food court instead of just hoping there's a spot.
And here's another pro move for you, this time for resilience. What do you do if your main AWS region gets totally slammed with traffic and slows down? Well, you can set up what are called cross-region inference profiles. This lets Bedrock automatically start sending requests to a different region that has free capacity. It's a fantastic way to build a much more durable application.
Okay, let's talk about something incredibly important: safety. Bedrock has a feature called Guardrails, and it's basically a powerful built-in safety net for your app. You can set up policies to automatically filter out harmful content, you can block entire topics that you don't want the model discussing, and you can even have it detect and redact sensitive personal information, things like names, emails, and credit card numbers.
But here's the thing to remember. Guardrails are just one layer of the onion. Real-world safety requires a multi-layered defense. It has to start with cleaning up user inputs. Then, you need defenses against prompt injection attacks. Then, you apply Bedrock Guardrails. And finally, you should always validate the model's final output to make sure it's in a safe, expected format. It's a whole process.
Phew. We have covered a ton of ground. So let's boil this entire playbook down to a simple one-page cheat sheet. These are the absolute key problems and the go-to solutions that you need to remember.
Okay, let's do a rapid-fire review. You've got a problem with hallucinations? The solution is RAG plus Guardrails. You're worried about sudden traffic spikes? The solution is cross-region inference profiles. You need to be able to swap out models without a headache? You build with the Converse API. You need guaranteed performance at scale? You use provisioned throughput. See the pattern here? For every one of these common production challenges, there's a specific architectural pattern that solves it.
Look, going from a cool demo to a durable, real-world AI application, it isn't magic. It's just good engineering. It's about making deliberate, smart choices about your model, about how you talk to it, and about the safety layers you build around it. You've got the playbook now. So the only question left is, what are you going to build?